This is problem 36 of Neetcode 150. Merge two sorted linked lists. Okay, so in this problem, we are given the head, so the first element or the starting element of two sorted linked lists. All right, and we want to combine them, and the result has to be in ascending order. So how do we do this? So what we are going to be willing to do, because we have to use space complexity of big O of 1, we are basically just going to use these two lists. We are not going to create another array or another list. So we are going to have our, let's call it linked list. Let's call this our linked list. Okay. Oh, pardon me. Looks like LinkedIn, but it's a linked list. And we are going to have, we are going to take a look at the first value here for both. Okay. And we are going to append the smallest value to, or we are not going to append, but we are going to set basically the next value of the linked list equal to the smallest one. So here we will set it to 1. All right. And after this, we are going to move our link or pointer for the top list by 1 value to the right. So just here. Okay. After this, we are going to look which one is the smallest between both. It's going to be 2. So we're going to add 2. One thing I forgot to mention is that we actually have to keep what I will call the runner. And the runner each time is going to go to the next value. So we are going to set basically the runner equals to that 2 here. And we want to keep basically our linked list and our runner. Both are going to be equal to that new output linked list. But at the end, the runner is going to point to the last element. So we want to keep something that points to the first element. So this is going to be our linked list, okay? So, okay, after this, we are going to move our runner by 1. All right, and we are going to move our pointer or our current node here by 1 to the right. Okay, so once again we are going to look at the smallest value. So here it is 3, so we are going to add 3 here. Once this is done, we move our pointer by 1 to the right, so it's going to be 5. And after this, we are going to move our runner by 1 to the right. All right, and after this, you got the drill. So after our 3, we're going to compare 5 and 4. 4 is going to be smaller, so we are going to add 4 here. Okay, and after this, once we go through every single values like this, after this, we're going to add 6. Then we're going to add 7. Then we're going to add 8. And finally 9. What? And at the end, our runner is going to be at the 9. So we are just going to basically return linked list that next, because we are going to be willing to go take that 1 value and render this. So we are going to render the head element of that new sorted linked list, and this is going to return basically the output that we are looking for, which is a linked list of the 2 linked lists in ascending order. So let's go ahead and code this. First, we are going to create our linked L, and we are going to set this equal to our runner. All right, and we're going to create the new list node that will basically be made of um, the two lists. Um, and there's one important thing also to consider here is basically that this new list node that we are creating is basically one fixed node that the rest is basically reused with our list 1 and list 2. So it has a space cost of basically big O of 1. If we instead created an actual array and we added with the append method the new element to it, then we will add a new element each time we will space with a space complexity of big O of n. But in our case, basically we are having we are reusing list 1 and list 2, so we are not creating more than a space cost of, but our space cost is going to be big O of 1. All right, so after this we are going to be willing to loop. We're going to use a while loop, and we're going to while until either the list 1 or the list 2 is empty. After this we are basically gonna add, so let's say list 1 and list 2. So once one of these break, basically we are gonna say runner.next. So once this while loop breaks, it means that either list 1 or list 2 is now empty, or we are reaching a null value. So we are gonna basically just append the rest of the other list to the next value of runner. All right, so once one of these two lists is done, basically we know that the rest of the other list is in ascending order, so we can add it. So runner.next is going to be equal at this point to which to the list that still has values in it. So we can do this by saying list 1 or list 2. So one of them might be null, and in this case the other one is going to be returned. It is going to be basically the next number of the runner. All right, and if both are null, well, we are just going to keep going and return the link l.next to reach the head element, just like this. And now it is time to create the logic of our while loop. So, all right, as discussed earlier, we want to check if which values is the smallest one, and we want to append, or we want to add. I would rather say we want to set the next value of the runner to that smallest value. So we are gonna say if list 1 dot val, because we can see here in the definition of a singly linked list that we can use a dot val to access the value at the current node in the linked list. All right, so if this value for list 1 is smaller than the value for the list 2, what do we do? Well, we're gonna say runner dot next is equal to list 1, and this is gonna point to the first element. And after this, we want to move our pointer in the list 1, so we're gonna say list 1 is gonna be equal to list 1 dot next. All right, so the other case is whether list 1 is greater or equal than list 2. In this case, we are just gonna say the runner dot next is equal to that head value at that moment in list 2, and we are gonna set list 2 to list 2 dot next. Okay, and at the end of this these checks, we want to make sure that the runner is actually pointing at the next value or the next node, because otherwise we will replace infinitely the same element in the link list. so we want to keep moving our runner forward. All right. So that's it. After this while loop, we are either gonna have list one and list two empty, and at this point, we are gonna just return the linked list because runner that next is gonna be equal to false and or null and null. So we are not gonna append to it, and otherwise we are gonna basically add the rest of the list that still has some values once the other one is expired. All right, so let's test this out. It should work. And there you go. So I hope you learned from this video. This was merge to sorted linked list, problem 35 of Neetcode 150. And I really hope to see you in the next one.